Hello, everyone. Welcome. Back for some game dev today. See, Key has already joined us. Hello, Key. Checking in with the kitties. We do have Ember crossing over the desk side, which looks like one of the cats has bumped that one. But Ember is joining me on my shoulder. We do have Mason, Sky, and Sammy on the bed. Molly wandering around the play area. Got a couple of bins out there. I've adjusted the cardboard box. There's a little toy that they seem to like. But so far Molly seems to be the type to just steal it and wander off. So we'll see on that. Might deploy it again. Time zone disparity, huh? Do be like that sometimes. Okay. Stuff and things. There we go. Okay, so there's still a lot of ground to cover in this one, but let's show where we got. So I've created a much more wiggly pattern here. Again, this is demonstrating what the map looks like. It won't actually look like that long term. But the black area is movable area. We do need to cover areas that you're not supposed to be able to move. But you can see how they're constrained to it. And we can see one of the problems right away. We'll see another one in a moment. So here and here are things that I would like to resolve, and I have some theories on how that might be possible, but given the nature of the simplified navigation, I might have to consider that a wash and just maybe have some failover logic for it. On the plus side, if we get to it today, avoidance logic will mitigate that to some extent. And that because entities won't want to pile on top of each other, and you're likely to get a lot of them at once, it's likely to cause both traffic jams as a whole, but it will mean that it's harder for them to hit those impassable areas because an entity will kind of fill the space. But we'll see. So the first thing I want to get to is the walls. It is trickier with walls because we need to have a hard push away on them. But we also don't want to search too far because the shader can't run that long. 32 seems to be about the limit for the search bubble, which makes it about 65 across for every pixel. Which it happens pretty fast, ultimately, an advantage of running it on the shader. But we'll have to see as far as keeping it working. Are you gonna sit with me, Amber? Are you? Huh? She's deciding. She's getting in the way of the camera as part of that. Which is why you can't see a lot of movement properly happening. Yeah. Ember is one of my 2 that are prone to skin acne. Chin acne. So I gotta keep an eye on that, and it's real uncomfortable to try to break it up in any fashion for them. So I try to comfort her when I can and avoid trying to clean it too frequently so that she doesn't have as bad a time. 20 streams in a row, Key. 20 streams in a row. Amber ear scratches. Okay. Yeah, you can see how they kind of wiggle in place. If I move along this way, it will free these two. And if I move along this way, the movement to the right starts to clear them out. There's probably kind of wiggle logic that I could add in to say, if I apply this vector to, say, 3 possible directions, like straight forward towards the target, but also maybe like 45 degrees off in both direction, is there one that is a longer vector? Try using that one, essentially. Because they would be, if they're caught down here, and I'm directly next to it, there are 2 possibilities that they could use. If I am perfectly aligned, there's really nothing I can do. But if, say, one of the vectors was to point down this way, and gets pushed away from the wall, and that one's longer, that might let them get closer. It's tricky to get that working. So as far as movement on the floor, I feel like for enemies we're at good enough. Amber. You gotta make up your mind, baby. You do. Because I'm a cat, I don't have to do that. Okay, back out. We'll look at what we're doing here. At the end of the last stream, we did have an error that was happening where the output was all these like weird squares. And I discovered the source of that. And that's that previously we had this. Where we just declared this vector. And I ran into a problem that is, again, one of those things that... Why did you do that? One of those things that you don't encounter in a lot of modern languages. Instead, you'll just get if it's an object, you get an exception that it's a null reference. If it's a simple type, it usually has a default value. So the default for a vector is usually the 0 vector, 0, 0. Hey there, Tas. So I did not initialize this. And on the GPU, we're dealing with like C++ sorts of memory management. Like it needs to be very precise. So by not allocating this, I believe, because changing this fixed it, my theory on it is that this contained whatever was in that memory address allocated to it before I started using it. And because I started using it by just adding to it, I was adding to whatever was already there. Is that actually what happened? Not sure. But, again, it fixed it. And my theory lines up. So if we go to our data, we go to our flow set, we look at the flow test. Boop, boop, boop. These are not meant to go during actual runtime. Like this image generation is not meant to be during actual runtime. So we can see our flow here. Today we need to get something to stop them from entering the wall space. So there needs to be a hard push away from wall space. We can accomplish that, I think, in 2 ways. We can treat a wall as having... So that's another way to put it. Open space seeks open space. So if I touch one of the, like I grab any one of these arbitrary ones here, are you not showing everything? Weird. It's not showing me all the values right now. There we go. If I pick this green here, on average, it wants to go this way. So it's saying the first value, well, the first value is to the left, the second value is down. So it's pushing towards generally the center of this little passage here. The red is pushing to the right and up. So again, pushing towards the center. There's a little bit of wiggle because it's a very narrow corridor. These are not actual, like, floor plans. And some degree of making a proper floor is going to be putting the spawn points, positioning them in relevant places on the map so that we can have enemies appearing in places that it is relevant. There are limits, but, you know, here we are. Words and things. But yeah, that's where we're going, is anytime that it finds floor space, it looks at it and says, okay, give me the summation of all vectors that point to, from me to open space. So any given pixel is going to say, point me at the majority of open space. It's not perfect, but here we are. Now, we can also add logic for the walls that say point to open space, but that won't get us the exterior space. Now we can create those boundaries, though. We can do two things with it. We can say, I think we need to just create boundaries. These create boundaries. If you're inside the space, there are noticeable forces that will push you away from a wall. We will need to make sure that we're enforcing that by probably adding some interior ones. That if a wall can find open space, it should use that. Additionally, if a wall finds dead space, like exterior space, it should push in that direction. Does create some border cases we need to be careful about, but I think those are solvable. Okay, so let's start with that. So what we're doing is we're searching over every pixel within a search range if it is floor space. We need to be cautious about this because this change is going to increase the cost of running the time duration of this algorithm. And there is a definite kind of risk surface to that. We can further subdivide it locally, but I don't know that local work groups are actually going to help us. We'll cross that bridge when we get there. So this is saying we're searching within the range of it. If we remove these boundaries, we can add a different marker to it. So we can have a different marker that says it's out of bounds. Okay. So we're going to change this to be if. I think we can get away with that. Godot, can I get away with that? Yes, I can. We are allowed to do that. So this is interim code that this negates this if statement. So we're searching through here. This is if it's in bounds. And then we're going to say else if. This is where out of bounds in the search. So we're going to say if floor color alpha is equal to 0 here. So let's explain ourselves. So we're going to say that if it's a wall, it's going to look for out of bounds space, and it's going to add vectors according to that out of bounds space. This is for if it is either of them, we are going to say move towards interior space. So first we'll run it with this. This should create the interior portions of walls. So we should see bigger than this showing. So it will have vectors further in this space that should push the entities further in. Let's find out if I broke it or not. There are two things that can happen here is we could get, okay, there we go. Now, they should be getting pushed into space here. Oh, okay. We've got some flaws in the logic. They are being blocked from entering that space. Okay, what are some of these? These are all saying up and left, up and left. This is saying search for this is from open space to us. So we have a pixel. For IJ, we're saying for each pixel within our search block, we get that color, which gives us our where we currently are as far as is it a wall or not. Then we're going to search over our range around it. If it's within bounds, if that part of the search is within bounds, then we still need we still need to check if it's a wall. No. Okay. That's why we have the problem here. So if we found open space, we are drawing a line from the searched location, from the spaces around it, and saying pull towards this one. This is the direction you should go when you're there. But this would imply it goes towards, like, wall spaces. Oh. No. This is if I found a wall, move towards open space. Yes. Okay. So all of them are from walls to open space. Let's add to this. So that's if we found a wall. This is if we find walls always push away from walls if they're in bounds. So if... Let's start with this, actually. So if we're open space and we found a wall, then we're going to push away from the wall. Oof. Hello, Ember. We can sort this if better. Let's balance cat carefully, otherwise she'll get agitated again. Okay, so if we are if we're a floor and we find a wall, then we push away from it. Ow, 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 ow. Ember's size makes it so that if she rests her forelegs on my shoulder, as she is wont to do, that puts her hind paws right on my collarbone. So if she gets agitated because I'm not petting her sufficiently, she will stand up, and part of doing that is flexing her hind claws so that she can get some purchase and keep her balance, which sinks said claws into collarbone and often sternum. Not fun. Okay, so if we are a floor and we found a wall, push away, otherwise push towards. This is push to open space. This will further push us to the center. So else, this means we are a wall space. If we're a wall space, and we found open space, we should push towards it. So again, push towards. No, it's this one. Push towards open space. This is from where we are to what we found. So we're going to check that in Godot. It doesn't mind that. Close use so that we can get our next result. Processes. Open it up and look at it while we wait here. Similar result. Okay, we need to account for that, but okay, we are seeing that as soon as they get near a open space, they get sucked into it. So if I go here and then move out, they're stuck in there now. Okay. Now we're saying if it's out of bounds. I'm going to move this out of here because we're going to be adjusting the direction either way. Same with this. Check the compile. Okay. Let's check that it runs again. Godot side does complain when we run, and it reveals something to us here. Actually, it blew up. Huh. That's generally not good when the editor crashes when you try to run it. It's usually a bad sign. Oh, dear, dear, dear. Why did it happen? I don't know. Why is it working now? I don't know. Okay, extra logic still working. So one of the things that we're going to need to do to make this work properly long-term for enemies is to say, if you are stuck, if you have not been able to move, I'm going to change their movement behavior in some way. That might just be to despawn them in some fashion. Okay, so now we have the interior flow. Push. If you're in a wall, get out of the wall as best you can. Like I said, there's a limit on this. 32 seems to be the limit so far. Again, this is for every pixel. Search 65 by 65 around it. That's a lot. That's a lot of processing we're doing. The GPU actually makes that viable. Before I change that, let's get our change in here. Don't care about that. Hey there, Thrax. Haven't seen that name in a while. That name looks familiar, though. Welcome, nonetheless. Seems familiar. My memory being what it is, it's kind of a toss-up, though. All right, so now we need to add a push away from open space. So we are a wall, and we are out of bounds. Ah, okay. And we never got back to that, but like many things, Maybe someday we'll find the next murder simulator to play. Okay, we're a wall and KL are out of bounds. If that's the case, I'm at dementia age for most of my life. I mean, real life comes first and dictates most things. There's wiggle room, but is what is. Okay, so we know we are out of bounds in some way here. A is greater than or equal to image width. This, and we do this for L. This is crude, but it'll do. Zero, we're going to avoid the garbage data problem. Okay, if it's less than 0, we need to go down. So that is, and this is our, I'm sorry, to the right, since this is our X value, our column value. So we are going to say 1, 0. It's to the right. That is to the left. This is down. And this is up. Ramen doesn't agree with your stomach there, Thrax? To normalize. How's the coding going? Pretty well, Ray. Pretty well. Let's see. To current is temporary. each iteration, we're going to say this is to move. Move, to move, to move, to move. We don't need to normalize here. Oh, okay, spicy ramen. Oh, what's the matter? What's the matter? Come here. Oh, you're heavy. What's the matter, Sky, huh? What's the matter, huh? Chin scratches for Sky. Okay. Indeed, Sky is well, he was jumping up and scratching at my arm and chair, so I've hauled him onto my lap for intensive attention. Ember hopped up to look and saw that Sky was holding her place. What am I working on today? We're working on our floor flow for entities that obey the floor. We're going to need to be cautious of how this flow works, though. Because we need... There are various elements to this. This one here, we're going to need to use a Z flag on this. First, we're going to get rid of this if true. Which puts us within this one. So that... Then we take... Oof. Yep. I... J... K... L... Should be able to put all of these here. Yeah. Unfortunately, for the shader language, we don't get that. I wonder if I can build that in, though. I'll have to look. There's got to be a way to do the syntax highlighting for GLSL. Yeah, it's probably in our editor settings somewhere. So I know I could force it for Notepad, but I don't know how it'll play. But we could probably tell it, pretend this is C. And we should get the right results. Godot, does this still compile? Yes, it does. Okay. So we're going to have to add extra logic that if the one that we're on is... almost certainly there's some sort of extension or something like that. I do like to avoid extensions for the same reason I like to avoid third-party libraries. Extensions especially are essentially saying, hey, this third-party code, keep it updated and let it execute. And that can be trouble. Because it can do stuff. If this is going to make things different. Okay, so if floor color is 0, oof. Hello, Amber. Hello, Amber. It says, I see Sky has moved, so it's shoulder time. All right. So if words and things, if it's a wall, we're going to set our Z value, our blue channel, to 1. This will be useful later. So we go back, we compile, everything's fine there, we run. Our shader runs. Okay, we did not get the push away. Oh, I think I did it backwards. Yes, I did it backwards. Okay, if we're out of bounds, to the left, we want that to be push left. And similar. So we're just going to reverse these. Compile the shader, run the code. I'm doing as much stuff in shader code as possible, Thrax, yes. We've got it to where our collision is being brute forced in shader code, and it is nice and zippy. That hitch there is creating a lot of these blobs in a circle. But during that hitch, more or less, there was the creation of a grid of movement. Okay, so they're hitting the exterior wall when that happens. They cannot enter that wall. There is gonna have to be some extra logic there. Oh, I hit the door. If I touch this little red dot, it's going to throw me into the center there. Okay, so this says you can't enter the wall from the outside. I don't know if this is going to stick. We might need to have some special logic for how that's going to work. Kind of don't want the exterior stuff. Reason being is if the enemy spawns off the edge of the map, they should just move in. Okay, let's pull that. This right here, we're going to remove the out of bounds logic. So they're going to phase through the wall. The reason that I want to incorporate that is if I have them spawn above the screen or below the screen, that didn't stick because I didn't recompile the shader, which is because I didn't go into Godot first. But let's look at that real quick. Okay, so the blue region is a wall. So anything with a blue channel, so this pink, the cyan, that kind of stuff, the white is get out of the wall. So as soon as you're near the floor, get shoved to the floor. Okay, we compiled that. This time when it runs... So they should continue into gray space, into wall space. But as soon as they get within range of the edge of a wall, they're going to get pulled in. Okay. Nice. Store that off. This is largely... this was also save off wall positions, but... Again, these are largely save states, not actually, like, reviewable commits. Okay, so we have wall information now. We know if a space is a wall. We have the floor flow, which is if you are obeying movement, if you are avoiding walls, this is how you move. This is not you collide with walls. Players and bullets are more likely to care about the blue channel, the Z value. Because they are... they just care about bumping into a wall. Then once we know it's a wall, we can consult the get out of the wall vector and push back against them in that fashion. It is not insurmountable to get out of the wall if you move fast enough, but we can make it very aggressive if we need to. Okay. So again, now let's just make this a little more plausible. It's hello, Ember. I acknowledge you. No, we need... top of the field, bottom of the field, and then bubble here. It technically doesn't have to be all black, it's just easier to see here. Don't want that. Again, this is, if we are being conscientious about map design, we have a lot of corners is what we want to have. I'm sorry, rounded corners is what we want to have. I Come on, Ember. So we run again. Oh. Sting. Here's rooms. Okay. Oh, I think I know what's going on. There we go. Okay, so this is a more plausible example. I'm going to stand here. Okay, that's wrong. Oh. Oh, no, it was... They were behaving correctly. Oh, okay. Little song and dance here. Select, invert selection. Delete. Save. Close. Go over to Godot so it recognizes it. This texture is baked into a scene right now. It is part of the texture rectangle there. And because of that, I have to open it in Godot so it rebuilds that particular scene. Okay, we've still got some errors in this vicinity. I don't know why they're stuck over there. Okay, let's look at our texture. Again, if it's got blue in it, that means there's wall there. These are all trying to push right and down a little. The orange space is all right and down a little. We're going to remove the push to open space. So we have a floor and we have found a wall. So we don't push to open space if we are not a wall. But Godot, check the compile. Ember kicks off my shoulder. Okay. So it's not perfect. You can still get into pinned positions for some of them. But again, most obstacles are more likely to be small ones, and we want to make sure that they don't have much in the way of big regions. This is a spawner, not a actual enemy. Nice. It can't really be pushed to open space. There's an extra layer of processing that we could do to essentially say push to like optimal space. So it is looking for a space that is not as close to walls. But we're already kind of accomplishing that. The reason that it would be pushed to space that is further from walls is that would push it away from like acute corners. Because those are definitely going to be closer to walls. We are going to need to be cautious about how this operates as far as how big these spaces are. It cannot be so big that it pushes enemies away from the player. And we can solve some of that by narrowing the search range. If we say 4, that means that it's a very tight bar around our collision surfaces. Yeah. So now they can be much closer to it. There is overlap. And we can still get where if it's a big enough wall, they can get into that perfect opposition. But it also means it's much harder. For one, you're more likely to get a circumstance where they have dodged the edge. So this is a very fiddly value that we're dealing with. But yeah, anything with a blue channel is, anything that has data in the blue channel is currently a wall. We'll need that for later. Any other color without a blue channel is it's open space and we're pushing away from the walls. With the wall, we're pushing out of the wall. It's functionally the same thing as far as what it does, but there's a distinction. We can use the "you are in the wall" vector to look at it and say, this is the closest thing to a collision plane. So if I look over here, eyedropper, where? There. So in this cyan area, how it says effectively go straight down. That's what the green channel is telling us. There's no red, there's only the green. So that is Y down. We have blue is 1 and alpha is 1. The alpha is 1 is so you can see it. We don't actually need that channel for this purpose. We may repurpose it to have a 4th data value, but for currently, it's just so that when we save it, we can see it. If I take that, so I hit this wall, it is a horizontal plane. That down is a vector representing that plane, that surface. So if a projectile hits this wall and we check and say, oh, it's got that downward plane, we can reflect our incoming angle along that plane. Similarly, with these curves, you can see it's a little bit different. So we are creating a different plane on them. It's not going to be perfect, but it's probably close enough. And we are in good enough land right now. This object is getting overloaded. That's okay. There is going to be a refactor. This object is for making the flows. Ideally, this object runs very infrequently. This is the one that everything will talk to in general, is give me the flow for this room. Give me the flow for getting to center kind of thing. This is where they'll go to get that, and if this one can't find it, it will try to make it using supplied information. Don't actually need to do that. That's an extraneous edit. Quick break, and then we'll be back to it. And we're back. Screen back here. There we go. Hello, Ember. It says you're back, so I get to be back on your shoulder. Because I have to be situated just so. Actually, a relevant little cat image you're using, Key. Ember is a diluted calico, so effectively, if you replace the black and white with like somewhat stripy, most of the black and white with stripy gray, but leave socks, white socks and underbelly, and that's what Ember looks like. The orange is paler as well. It's not quite tan, but close. So Ember's adoption was kind of serendipity, coincidence, however you want to look at it. I was passing through a rescue with somebody else. They were there to adopt a dog, and of course, I looked at the cats. But as I was turning to walk away from the little cage that they had some of the kittens in, where Ember was, she reached out and like grabbed at my shirt. And that was it. It was very much a, well, I guess we're doing this. For the most part, it's why I have to do things like try to avoid the adoption areas in pet stores and the like. The local PetSmart works with several of the shelters in the area for their cat adoption area, and I try to avoid looking too closely there. Molly got adopted because I got too close and realized that. Well, Molly and Sammy to some extent. So, Molly because her sibling was adopted and she wasn't. Sammy similarly, not too surprising because her sibling had not adapted fully to being indoors, was still full on barn cat behavior, so did not socialize well with humans. But the idea of, breaking up especially when it's just like the pair left, breaking up the pair is kind of sad. Especially when you're dealing with a shelter situation, because then one gets left behind in the shelter. That's why Mason and Sherbet were adopted together. That's why my first two cats, Bob and Tom, were adopted together, is to make sure that they had that sort of like pre-existing family unit to give them some stability. I now have two cats on me. I have Ember on my shoulder, and Molly has joined me on my lap. All hands detained. Not even ASMR. There's just There's just cats being pet. You'll have to trust me. Yep. Reach across and hit the button. Not sure where Mason has gotten off to. Sure. Oh, hello. Speak of the devil. I said his name, and I looked over, and I spotted Sherbet. He's snoozing in the cat carrier that, if I were to try to, put him in that and take him to the vet, he would flip right out. But that's one of his napping spots, because when it's not zipped closed, it's a little snoozing box. As I was looking down, I mentioned Mason, and his head just pops up in my field of view like, hey there. Oof. Okay. So now we're looking at avoidance, and avoidance is a more complex operation. Mason really likes back scratches. He likes belly rubs as well, to a lesser extent, but really back scratches. The trick is that he generally doesn't put himself in positions where he can easily get them passively. I often have to kind of either pull him into that position or encourage him to like jump up on the table near me, so that it isn't like, you got to make up your mind, Molly. If I can get him to jump up on a table, it's easier to give him attention than it is if he's constantly just hanging out on the floor. Then he can get passive attention regardless of what I'm up to. Change their water again. Seen some build up on the fur. Yeah, I'm sorry. Okay, so let's do our shader collision manager. Let's look at it. So we have our entity data that we're tracking in here. Should be our collider data bytes here. Do our on. So when we do on entity added, we're going to go in and we're going to get our colliders. So it's our shader colliders. There we go. So we have our shader collider object. We're going to use this to build up our pipeline. Collider changed. It's going to listen to the object. We're going to update collider data. We cast that data. We look for the entity ID. We update its data. So we're using the shader collider objects here to relay an event over. Then we are updating the bytes directly by casting them in this fashion. This is a handy trick when we're dealing with bytes. We're not allocating a new array and copying into it. We're just saying this byte array, it is the same shape. Sorry, it is the same length as it would need to be for it to contain shader collider data. Treat it as if it contains shader collider data. So if we write to the shader colliders in this this span here, then we're updating the bytes correspondingly without having to do copies. Okay. So we need a similar structure to keep track of. We'll update their bytes, then we will pass it to the shader, and the shader will spit out the raw data. We'll save the raw data as an image in the same way we have been. Actually, no, we won't save it in an image. That will be grotesquely expensive because this will be happening every physics frame. We'll need to do it at about the same time because we need it before the next movement tick. Okay, we need a new service for this. It is physics adjacent, but it isn't really. It is a flow-related object. So I feel like I'm going to make it part of the flow manager. So this is going to be avoidance. This makes the avoidance flow repeatedly. So when it gets created, when it activates, we're going to scope it in the same way. It's going to get references to, or it's going to subscribe to entity creation events so that it can create objects that it will relay in the same way that the physics generation does. Just a second. Let's pull this up so I can parse through. We're gonna do this without flashbanging you guys. You folks. Okay. So we have our entity manager. Whenever an entity is added, we have an event here that is our entity added. So we are going to listen for this. Let's call you E. So we get an entity added event. Then we have our flow generator is going to get that entity added, and it will add one. Then that will have a something akin to avoidable updated. Let's move you. This makes a new object which emits this message. Interesting. Why is this so small for it? There we go. Sure, why wouldn't we use the other options that are available for things like size of it? It is truly terrible. Anyway, so we are going to do this. A flip horizontal. Of course we don't. Oh, no, no. Rotate. Yeah. Okay, so what each entity does, when we get an entity added, we go in, we create one of these. Then we also have this is the entity that was added. Then we're going to look for position updates. Okay, so if we add an entity, there is a corresponding entity that gets created here. If that entity's position changes, this one says, hey, update this information. This allows us to have a concise object here that is just, where am I and probably how big am I? This is something that we should be able to contain once again in a vector 4, which is convenient. So what this will do is we now have that data. We have it ready to be loaded into a buffer. We update that buffer and we pass it along to the shader. The shader is going to create a corresponding set of data for the entire region that these entities exist in. This is tricky. We're going to need an offset. So we create this region that is the same size as the flow to center, which is, I think 3 screens across and 3 screens in each direction. So a 3 screens by 3 screens centered on the player. If the entity is outside of that boundary, we don't care. They do not do any avoidance. We can actually make it tighter than that, and say and then off-center it, and then center it on the player the same way we do flow to center. As soon as an entity is within range of that, we are now consulting that area and saying which way should they move based on the flow that we generate each time. We're going to be doing this at the same time that we do physics. So after the entities move, we kick off a compute shader, and at the top, at game step started, we pull that information and make it available in an output array. That makes it so that subsequently, whenever we're asking how an entity should move, we can consult it. So this collection of information inside of this thing is we're going to have then let's just do a size vector 2. For the time being, we're going to make them squares. We'll figure out how to do it a little better. So what this will do is we're going to create, let's do purple here. So we'll have our screen space. And each one of these is going to create little bubbles in it. That each time we create these little bubbles and fill in the space. So we're going to generate around each of these entities bubbles to say, these are spaces that are filled in some way. And then we'll be creating vectors away from that space. So this one is almost 2-stage, and that's tricky. We don't need to create the bubbles, actually. The bubbles are just conceptual. So at each point, we are going to look around it. It will actually be more like this. So we have a point that we're looking at. And that point is going to look around it in particular ranges to find where the other circles are. And it will push away from those circles. So if an entity for this area, it's going to look at it and say, okay, is there an entity within that range? But how can we do that efficiently? I don't want to have to iterate over all entities again, but we might need to. And I don't want to have to do this in 2 stages. Because we would need the same data twice, and that creates a 2-frame gap. We don't want to have to rely on a 2-frame gap. The shader could translate the information. We could create a secondary buffer for that. But that's not universal. Okay, but this is what we're trying to create, is we have positions and sizes for the entities. We want to be able to say, there is an entity here. It can't be a set, and it can't be a dictionary. We could make it a dictionary, but that's, again, wasted time on each pass. I could still just have it iterate over it. So for every space, it's going to iterate over all of the entities. And say, are any of them within this range? Again, wasteful, but it's on the GPU. We might be able to get away with it. I feel like there's a better way to do this. But for the time being, we're just going to have to deal. Because again, I don't want to have to run 2 consecutive compute shaders. This is one that we might be able to multi-thread, but that is... anytime might be able to thread comes up, it's probably best to avoid it on first pass. Okay, so we'll have the entity data. We might not need size as a result. Interesting. Oh well. Because if we're just looking at their position, no, we'll keep the size. So when we look at the entity and say, okay, is this space within range of this entity? So we would first look at our search range and compare that to the entity size on the position. If the search range is within the size, then we have it would be if search range plus, like in this case, the radius gets us within distance of the entity, then that counts and we push away from that position. It's not perfect because it requires that it aims to center, but I feel like that's going to be good enough. if it's not clear, the reason we're doing this is so that enemies don't stand on top of each other. We want them to kind of jiggle away from each other. Started with that one. So what do we want to put on this? We'll see what we need to make it. Really, there's just going to be a get method. And this one might call out to the manager and say, here is an updated flow for it. Yeah, that might ultimately be the way that we have to go about it, is that entities themselves broadcast what it's going to be. We'll circle back around to that later. That's a next stage refactor. Basse. Stop trying to be weird, helpful in an unhelpful way. But it's flow generator. Keep that. That's useful enough. This is Godot. Godot 4.5 currently, Panda. We're writing in C. This is C# and Visual Studio. But our engine is Godot. We are currently working on our logic that will make it so that enemies avoid each other, so that they don't pile on top of each other. We are using special logic for that because there's going to be a lot of enemies. A lot. I started with VS Code. I'm just used to Visual Studio, so the differences between VS Code and Visual Studio were a problem for me. So, lots and lots of enemies. Today we've got the logic for avoiding walls in place where they can. But now we want it so that they don't all stack on top of each other like they can right now. We are not using a lot of the built-in logic for Godot. All of this code base is a vast majority of the game's logic. As little as possible is actually happening in the base way the Godot engine works. We're using it as a vehicle for rendering and timing. There are just too many performance considerations for the other stuff. Okay, so it gets created. So it's going to say we need entity manager. Services dot solve entity manager. So we get an entity manager. Entity manager dot entity added. Add entity. No. We don't do the entity manager. It is emits entity added. Emits entity added is equal to services dot resolve that. It's entity added dot entity added plus equals that. Say on entity added. Do I know exactly what to code? No. Not in advance. I have a general structure in mind, and we just kind of roll with it. We're doing this live, so a lot of this stream is stream of consciousness. Is just me saying, okay, this is what I plan to do. This is what I'm doing, and why. And sometimes that doesn't work, and we have to do it differently. The idea of looking up how to do it every time, that's normal. That is entirely normal, and really anybody that tells you otherwise is being kind of elitist, at least a little. You will learn to not have to look up some things. You'll have it memorized. But part of learning is finding the information. In fact, part of coding is learning to find information, when to trust where you found it and when not. Sometimes that's looking up the base documentation. Godot has a lot of that. I expect Unity and Unreal Engine and GameMaker all have documentation of some kind somewhere. Sometimes it's looking at that. Sometimes it's going to Google or YouTube or something. We live in an age where all of this information, all of the so much experience of programmers is available to you in a search engine that it's foolish not to use it. When I started programming, all of the knowledge was available in hard to reach places like individual websites, maybe using search engines that were less reliable often, or books. And now you can search and you can find a lot of places that are usually trustworthy for it. So absolutely use those. The only thing that I would say you want to have a strong idea of and keep that idea in mind, even if it changes over time, is what the gameplay is, so that you can move towards it constantly. That's it. Otherwise, you just sort of roll with it. Should I have a design document and update it and keep track of my ideas and how things are supposed to work? I should. That would be a professional thing to do, but that's not how we work on this stream. All of this is in my head. So sometimes part of the stream will be me reciting what I think it's supposed to do and finding where it does that so I work with it correctly. We've done a lot of refactoring to make it so that that's easier. It took me a moment to remember where you get this message, but this is a much simpler way to do it. I don't need to care what emits the message. I just go to the thing that emits the message. Like, this is what everybody gets that message from. Any number of things could emit it, but this is where that event comes from. So we're basing this largely on our shader collider. This is my first game, my first major project with C#, the first time I've used Godot. This whole project has been a learning experience. I believe this is stream number 174. On entity added. Don't need the collider key. These are shader collider objects, and this is what we're going to use for it. It doesn't need to be an actual object. We only care about shader collider data, which is this stuff, this structure. So we have that structure, and we have an entity to track it. How much have I completed? So the base game flow continues to be relatively static. We have basic mechanisms like emitting projectiles, hitting enemies, spawning enemies. We're building up the bones of being able to load a map. What we're working on right now is what we've just finished today is logic for generating how entities can move how enemies can move in a room without being able to phase through walls from the inside. They can walk through walls from the outside if they get spawned outside, but they run into walls. We have our core weapon system. So this little mouse that gets emitted each second homes in on an enemy. But we can make it fire 3 times a second and split into 3 as well. And we can make that circle around us and do a little sine wave while you're doing it. It emits like 500 blobs at once, so unless I make, well, and we're not using Godot systems because we want to be able to do stuff like this. Three times a second, we're going to emit a projectile that splits into 3 6 times in a row. So we are going to emit 3 to the 7th projectiles per second, and they will orbit around us. The game will slow down, but less than you might think for what we're doing. Now you can see that the rendering is slowing down, but we're still going to get more physics ticks than you might expect. We currently have there are 10,000 moving things on the screen. 14,000. As far as the game is going, there are 10 frames per second still being processed. Now, rendering-wise, it slows down a lot. World simulation-wise, it is still slower. But we don't have our input hobbled as much as it could be. So we're at 18,000 things and we're getting 8 frames a second as far as the system processing. About 19,500. The blobs are being steadily shredded. We just got a wave of entities removed. It should pop back up. But then we can just drop it all the way back down. It'll take upwards of it's going to take at least 30 seconds to a minute before these all go away. They normally last about 10 seconds, but that is 10 seconds kind of time dilated. So that central, we're getting kind of a ring forming now instead of a kind of a circle. What's the goal with the shooting? Highly customized weaponry to clear out enemies. If you're familiar with games like Vampire Survivors, that's kind of the vibe. Lots of enemies, spectacular weaponry going everywhere, with the added wrinkle that instead of having weapons that linearly upgrade and combine, instead we're going to be working on base weapons that have their behavior altered by upgrades that you find and socket in particular orders. I can see that. Binding of Isaac already has lives in a similar domain to Hades as far as room-by-room battles. That's kind of where we're going. The extra seasoning that we're putting in is weaponry like a game called Noida. The reason that we're going for such very high projectile markers in performance optimization is because we want to be able to handle that fringe case, that what I call a calamity case. It is where the game's engine is taxed as greatly as possible because I want to be able to have something that is just spectacular. I don't have anything that we can test with that. But, like I said, today we got enemies obeying walls. What we're trying to add to it, I don't know how far we'll get, is enemies avoiding each other so they don't stack on top of each other. Again, without using any sort of Godot level navigation because there's way too many things. There's just way too many things. I have seen discussions of optimizations that would allow you to do it, but those still, I think, factored into hundreds of things with tight optimization using those systems. We're dealing with thousands of things. Okay. So we need a structure that represents the data that we're going to replicate. And that is in our interface. Yep. Godot has similar. There's a full, body physics engine that part of the Godot engine that you can use. But even just using the objects bump into each other, let alone objects can collide with walls. That's few hundred objects tightly optimized territory. Maybe more with additional shenanigans to avoid objects that aren't, that you can kind of lump together. But once you get into this is a object that this must collide with and stop, things get wild as far as the cost of that. But if you're dealing with maybe like 20 dudes on the screen, then built-in collision objects and whatnot get to be way more attractive because they're likely going to work sufficiently speedy. Again, in a world where we're probably looking at 1,000 things running around on the regular, the math is different. Okay, so we need a layout kind sequential data here. What are we calling it? And we need the same thing here. This is saying that the order in which I put them in this structure is the order in which they appear in memory. Do not try to optimize yourself. Put them in this exact order. Yep, timing is how you do things like stop time as far as pause screens varies a lot. I'm doing that by having a separate layer of loop as far as the physics is concerned. If I were using the base Godot stuff, I would need to use different structures. There is like a pause that you can do at various levels in Godot. I'm doing it by saying, do not move the simulation, the movement and collision and spawning and whatnot. Do not send time to those objects while the game is paused. But time still continues. I could probably do it with Godot pausing as well. We might circle back around to that. But we need to make sure that we're not sending time to the wrong places during that period. Vector 4. Am I using a vector 2 or using Godot? I could do this as raw floats and ensure it's in the sequence that I want. I think I might be able to do 2 vector 2s and do this cleanly. Oh, let's try it. So the reason I have to consider this is that if you use a vector, then the shader wants it to be in a 4-byte packet. I'm not certain that it will take this and say, 16 bytes, 4 bytes per float. It wants it to be in a 16 byte. So this is an 8 byte and this is an 8 byte. I don't know for sure that it's going to say, okay, then this is 16. So it is a clean block. It might say that there is something here and here that creates dead space. But I think we can get away with this because it is consecutive vectors. We can see the problem appearing, how the problem appeared over here. So I have 4 floats, or 4 4-byte objects. So we have a 16. Now I have 2 4-byte objects for this part of the data. And then another 4-byte object. This gives us 12. We have 4 remaining. But this is a vector 2, and vectors want to be, or are required to be, or something like that, need to be as at the start of a 16-byte chunk. So I have this variable here, this dead space, which is padding space. I think there are other ways that I could wrangle this, but this ensures that it is shaped the way I want it to be. So again, block 2, another 16. Then we have the vector 2, but this technically, I believe, is going to take up the whole 16 in the structure. So there would be 3 dead spaces, 3 or 12 bytes of like reserved space after this. But as far as loading the memory is concerned, this should be okay. The translation between this and the GPU would handle the addition at the end, the tailing value. Long story short, I think this will work. But I'm not sure. Okay, then we need to get our shader collider data. State, physics, not physics, state, collision, shader-based collider. This is an iShader collider. Catalogable, it has an entity, and it has corresponding data that it can pass along so that it gets updated. This thing is not catalogable. This is just going to be a thing. Shader colliders, I have, like, they are shapes. So like a shader collider circle is a shader collider. So we don't need that level of complexity. We're still going to keep our avoidance data here, and I think we can have a secondary contained object. We could, but we're not gonna. And we're doing this because we need the entity. Just an event, it does not pass a message. Oh, it does pass a shader collider changed message. Hey Lunar, did I add the Manage a Dating app facility? It has a mini game that plays like a dating sim, which sole purpose is to gather test subjects. Okay, it's world steps, that's physics steps. Physics steps for the collision shader. Add a folder for avoidance. Let's add entity avoidance. Changed message. Okay, the emit game message. Entity avoidance, remove message. Same thing. So we're setting up the events that will be related to an entity getting added. So there is an intermediary. The avoidance generator is listening for entities being added. When they're added, we create a entity avoidance object. That object contains information about the entity that we're dealing with and its and a corresponding structure that is what that information is. So this is like where it is and what its shape is, or what its size is. There is a correlation with the collision system on this that, oh boy. That is a layer of complexity that I don't necessarily want to approach right now. But it does mean that we might need to get the collider information that the shader relies on or the collision relies on. And some of that might just end up being us settling on how we do collision and saying these two objects needs to be compatible. As in, the collider needs to be something that everything can interpret properly. It should be that way anyhow. So this is a removal message. It doesn't really need to have a lot to it. So this is, which collider are we talking about? This one is, which collider are we talking about? So we need the corresponding entity down here in avoidance, where we add our, it's not an eye shader collider, this is an entity This is entity avoidance. Collision manager. Where that data is. Shader collider is where the structure is. So in that way, our structure shouldn't be in the avoidance flow generator one. It should be in the base entity avoidance one. And this is using Godot as a result. Avoidance. So create it, we set, it has a data structure and it has the entity there. So when this one is created, when the entity gets set, this is just going to return entity. And when we set, okay, so when we get a new entity, we are going to attach, we're going to make sure we detach any events that are there if it's not null, if it isn't currently null. Hello, Ember. Hello. Ember says, I'm chilly and Molly's in my spot. Molly has commandeered Ember's favorite spot. Generally, Molly doesn't crowd her frequently, but Ember doesn't like other cats like napping near her unless there's Sky. Frequently. She doesn't always tolerate Sky. Normally, she sits at the keyboard because that gives her something to rest her head against, while still being nearby. She is a close orbit cat. Molly frequently naps in close orbit, Molly naps in close orbit most of the time. She's either in Ember's spot, or she's under my feet. Attach entity events. Ma'am. Oh, Okay, we're going to take a quick break, and then we're going to push on through to the end here. Be right back. That's not the right button. This is the button. Okay. Attach events and detach events. Hello. It is a little bit chilly, so it's not too surprising that Ember is being extra snuggly. Ember is itty bitty, so she gets colder easier. Do wish I could figure out a way to I wish there was an option to calibrate my my audio filtering to allow cat purrs through. about animation changed. Position updated plus equals that. Ma'am. She's orbiting today. She jumps up, she gets back scratches and ear pets, just soaks up attention, and then she's like, okay, I'm done, stands up, hops down, loops around after a couple of minutes. Says, more pets, please. Make up your mind, ma'am. Because I'm a cat, I don't have to do that. That's right. That's right. Reach here. Oh, she's got the wrong arm detained for this part. There and here. Do the same thing here, except we do minus equals to detach the events. So here we update data. Changed. Okay, so then up here we've got event handler. Is entity avoidance changed message. We're just actually going to call you changed. Handler entity avoidance. Remove message. Remove. This is remove if it exists. Invoke it with this and relay actually. Entity avoidance, remove message with click that value set. Okay. Then in our message here for our remove, we're going to take the same thing. For changed, we're going to do the same thing there. Okay. Data.position. Oh, ran into this previously too. I mean, it's not a variable. That's odd. Let's... Data is being updated. Double check the public struct. Public struct. Doesn't actually need to be a property. That's public. It shouldn't be underscored. There we go. Okay, so this is the reason that we're going to have to come up with different information. Like, Collider should have data surrounding it that our shaders can, that our logic can uniformly handle. Because this is collision related. For the time being, though, we're gonna kind of fudge the numbers on this. And just say that entities can't be within 4 of the center of another. So bigger entities are going to potentially run into problems with that. cross that bridge when we get there. So we create it, we set its entity, and... Okay, so then we're also going to... We need to immediately update the values for this to work. But that's okay. That's okay. When it's added, the subsequent events should be sufficient. He said. A protected... There. Anytime we need to update the data, we can call that. Won't need to do it constantly, though. Then in our generator, whenever an entity is added, we need to update a collection that we've got. We remove a shader collider. What are we doing? Okay, yeah, it's for the entity that we're creating it. So we're tracking them by the entity. And then when we add an entity, adding it by the ID. Just detaching the event. Okay, remove collider data. Go to... We're removing it by entity ID. Okay. Okay. So then in this, it's a dictionary from uint to... What? An entity avoidance. Initialize it. Okay, so now we have that on entity added. We have an entity avoidance. Entity avoidance. Hey, Jesse. So, one, thanks for the compliment. I do like how the model turned out. The artist did good job, good work. I like C#. I'm liking what I've got with Godot. I feel like I'm interested in other platforms. Maybe on future projects I'll poke those, but I like the pattern that I'm using, and that's that the engine is only touched when it has to be. Almost everything I've got in this game is done on the C# side. We are making a survivors-like game. I'm sorry. It has elements of Vampire Survivors and a game called Noida. Noida has a special place for our channel. We played it a great deal, we liked it a lot, and now we shall never play it again. But there are elements of it that I still love. So this is our demo stuff right now. Lots of enemies spawn, they converge on you, you fire weapons all around you to try to stop them from touching you. The Noida influence is the ability to add sequential effects to the weaponry to make it behave differently. Let's do that a little a little sooner, otherwise there won't be enough time. I use these because the effect is very visible. So we're going to do these from left to right. This is not the icon for it. This is a thing that should only exist in testing, so it doesn't have a real icon. We have the homing mouse. By default, it does 1 damage, and it will home in on a random enemy target when it appears. I believe if it loses its target, it tries to acquire a new one. Haven't checked on that. And it lives for about 10 to 12 seconds, I believe. 3 times a second, we will emit one. It pulses at once per second, but this upgrade says whenever you pulse, do 1 every third of a second. So another one is emitted from the same spot on third of a second intervals. Then we wait 3 seconds. After those 3 seconds, we're going to split into 3, then split into 3, then split into 3, then split into 3, then split into 3. So we have 3 to the 6th things being created here, with 3 to the 5th being created after 3 seconds. Then also after those 3 seconds, it will begin to try to orbit the player at a particular radius. This is the Noida influence. So you can see the 1, 2, 3, 1, 2, 3, and then they will explode into a whole bunch more and start to orbit. What we're seeing here is why I do almost all the code in C and why we do a lot of optimization. But thank you, Jesse. Thank you. I appreciate it. Avoidance, entity is equal to e.entity. This is avoidance is not add. The avoidance. Avoidance changed. Avoidance dot remove equals on avoidance remove. attach avoidance events. We're going to have detach avoidance events. Attach them. Up. E dot entity avoidance dot entity dot ID detach avoidance events E dot entity avoidance. Then on changed. So now we are going to need our protected byte array. Let's look at our shader collider so that we can get an idea of how we created that. Collider data bytes. Need something, something like that in our base generator here. Buys bytes. And that is the size of entity avoidance data. Here. So then here we are going to initialize our avoidance data bytes. We can't short circuit it that way because we need to know how big the data is before we can do that. Collider data bytes. Here. Underscore avoidance data bytes. Okay, so now we have avoidance data of the appropriate size for the entity. Going to need to be another element of the avoidance data. Ignition. So collidable. This is relevant. We don't actually want... So we need an active value. So now I doubly don't know if this will work. If it doesn't work, we turn this into a vector 4 and essentially fudge that there's two values. Because I don't want to have two padding variables between them. That's a waste of space anyway. Okay, so in the avoidance flow generator, when we remove one, we need to update the data on it. And ID. It's data. So first we need to cast the variable here. Just going to copy that whole thing over and make use of it. We'll explain this in a moment. Let's see, from Roger, starting Unity until the EACO decide to charge for installs. And Unreal, like everyone else, and it has optimization issues. Godot is my last attempt. Yeah, it's... I had originally dabbled in Unity, like poked it a couple of times to see what I liked or didn't like about it. And at the time, what I didn't like is that getting C# DLLs wired into it, let alone the being able to use ones with more modern versions of C# or more modern compilers for C# was burdensome. And then Unity's executives came along and massively dropped the PR ball. So I decided, yeah, let's not do Unity for our first project. Unreal Engine, the project I'm working on really isn't of... I don't need Unreal Engine. Let's put it that way. So Godot was called out as an alternative to Unity, and I was curious, so I started messing with Godot, and we've just been running with it. Optimization-wise, a lot of the footwork is being done in my own code. It really depends on what you're trying to do. I mean, it's a lot like Unity in that regard. Span of entity avoidance data. And this is... It is a big deal for the project. Let me demonstrated this a little bit earlier. I don't know if you were here for this, Jesse. Let's do the overkill one. How I refer to them is calamity cases, and the idea is it is very unlikely that the player would ever reach this level of ridiculous, but if they do, the game should not crash or become completely unplayable. So this is 3 to the 7th projectiles per second. Doing non-simple movement. Each projectile is an individual entity that can move in its own fashion. So we can't do things like classic just use particles to represent the bullets kind of stuff, because each one could behave completely different than another. Raw game processing, like the actual executable, is still running at 10 frames per second currently. The world operates at, I can't remember if it's 30 to 60 segments of a second. No matter how slow it gets or how fast it gets, the world tick is a fixed size. So we don't have to worry about entities like warping through walls or or any number of other elements. So you can see it's moving real slow right now. But there's 19,000 things moving on screen right now. Moving on screen, there's actually like at least double that in background objects. So we've got 7 frames per second right now. The player should never reach this. This is effectively, I win. That, and you can't have more than 20,000 entities, so you get things like bullets stop spawning at that point. But let's cut two powers out of it here. So this will drop us down to merely 2 to the 5th. I'm sorry, 3 to the 5th. And it takes 10 simulation seconds to actually clear all of these projectiles. There'll still be a whole ton of them. But it's a lot less. So at 2 to the 5th, we're sitting at about 15,000 things still. And this whole surface is effectively a death blender as far as enemies would be concerned. There's just no space to get past it. Then we can cut another one down, and it will slow down further. So now as they fade, there's going to be fewer and fewer replacing them. Let's get that last entity out of the way. So you can see the individual motion happening here. When I move, they're trying to orbit me. So they're having to kind of course correct individually. So it creates this sort of like orbital slingshot kind of vibe. But yeah, performance has been a big deal. We have refactored the whole program a couple of times to account for that. Part of what's allowing us to do that is all collision is a shader. It's all handled on the GPU. we kick it off at the end of a frame and then process it at the start of the next frame, so it has time to operate. To some extent, we're doing some stuff on the shader just because it's a good learning opportunity. But some things we're doing on the shader because it's just too performance intensive otherwise, too many permutations. So we need to update avoidance data when we get this. And we're going to pass in e dot avoidance.entity.id e. So we get the entity ID and we get the data. We just update that data. And when we're updating the data, we're going into the byte array, we're casting it to we are overlaying it as a span of avoidance data, and we're just setting the data over top of it. Data is a struct, so it's just setting simple types over top. Okay. Just check something here. And that. I think this is a good wrap-up spot for the day. Primarily because we're heading into and now we need to set up a shader aspect of this. And there's a lot of song and dance that goes along with it. So I think that'll be a good starting point for ideally tomorrow. Fingers crossed and all that. Next stream should be tomorrow. I'll get it set up either tonight or in the morning. But yeah, we got the actual map navigation going. So progress. It's not perfect, but it's good enough. It's good enough. Well, thanks for swinging through, Jesse. Thanks for swinging through returning viewers and new folks. Always appreciate it. Now, if you like what you saw and would like to see more, remember to like, follow, subscribe, comment, all of that stuff. Those buttons are generally good. I'd appreciate it if you press them. If you'd like to consider financially supporting the channel, you can do so through platform-specific individual platform means, as well as some additional options findable through the link tree in my profile and video descriptions. But with that said, I hope the rest of your day is good, and I will see you next time.